Welcome to Spring LIB.
Okay, we have conversion of an alcohol, specifically one thing that's worth noting is that this is not a stereocenter, right? If this is a methyl group and this is a methyl group, then effectively there is no difference between the molecule that I've drawn there, or that you've drawn, and if I had drawn it with a wedge here, right? Because if you've got two of the same functional group, then you no longer have stereochemistry. So a more appropriate way to draw this molecule might be to leave out the stereochemistry altogether, like so. Nevertheless, if this was an oversight and this is meant to be an ethyl or this is some other group, we can go about this as if we were maintaining the stereochemistry, just for the purposes of meeting what may have been the intention of this question. So the question is, how do you convert an alcohol into an ethoxide while maintaining the relative stereochemistry? And so there's two ways to do that. The first way is to treat the alcohol with sodium hydride, which will act as a base to deprotonate the alcohol. Right. And then this can act as a nucleophile upon, say, an ethyl bromide, right, to do an SN2 reaction and convert the alkoxide into an ethoxide while maintaining the relative stereochemistry. So that's option one. But this isn't a particularly good nucleophile, right? This is a tertiary carbon. This is basically like T-butoxide, which we know to be not a particularly great nucleophile in either case, but it would theoretically work. Okay, so the other option is to do the following. Okay, so we can do a sort of double displacement where in the first case we may use tosyl chloride to make a tosylate, turn our OH into a good leaving group, like so. Displace it with something like sodium iodide, right? This would replace our tosylate with an iota group, but also invert the stereochemistry. Okay, and then do another SN2 reaction, this time with sodium ethoxide. Right, which would, again, iota group would be the leaving group, ethoxide would be the nucleophile, but we would get inversion because this is an SN2 reaction again. And so that inversion would bring us back to the original stereochemistry. Right, so the option is activate the alcohol and perform a displacement with some halide, either bromide or iodide, and then do a displacement reaction with ethoxide to get back to the original stereochemistry, or to use sodium hydride or some other strong base weak nucleophile to deprotonate the alcohol, creating the alkoxide, which we would then use to displace bromine and an ethyl bromide to get access to this ethyl group here.